Which one? The one which is... The point.
درست هم می‌دارد که بید.
Thank you. The title is now, sorry. Key laser parameters for optical limiting and laser safety application. Indeed, in today's world, a single short pulse may only last for picosecond or femtosecond. And this is a very short time duration, which can damage permanently eye, skin, or optical sensors, optical devices like detector, photodiodes. Understanding the parameters behind these high pulses is no longer optional, it's essential in fact. Lasers everywhere in our daily life, from the research lab and the medical clinics to the, for example, barcode reader or even the pointers, which has become very high labels, and you can buy like these lasers in just for $3. Here, for this case, we will try to manage the optical limiting and also for laser safety methods. In this seminar, I will try to make explanation for the optical limiting concept, why it's important and what's the principles. And then going through the key laser parameters which control the optical limiting and design the laser safety. These parameters, which is the main goal for this seminar, is including the laser influence, laser intensity of, and laser pulse duration, laser pulse rotation rate, and also laser incident angle. These parameters collectively affect the optical limitings and design the system for the laser safety. Okay, for the optical limiting is very simple in fact. The idea is that the optical limiting means the material will start to reduce the intensity of the laser when the influence of the laser is increased. And this kind of techniques is very important in high peak intensity lasers, especially in the nanophotonics. Sorry. The principles of the optical limiting is especially important in nanophotonics because in nanophotonics we have the laser interaction matter will be much shorter, faster, and more nonlinear. And it was basically the nonlinearity increased when we have the high intensity. For the nanoscale system, easily can be damaged when we have a high intensity compared to the bulk material. In this diagram, we will try to explain the basic principle of the optical limiting. Optical limiting, in fact, can be assessed through a concept of optical limiting threshold, which is the minimum intensity that the intensity of the laser can drop down, or the transmission will be dropped down when the material goes to the high intensity peak. The two regions we have, before threshold and after threshold. Before threshold, the intensity will be almost linear, means the intensity will increase with increasing the intensity of the laser, and then the transmission will be increased. After the threshold, I mean above the threshold point, then the transmission will drop down or significantly drop with the high intensity of the laser. This region is called non-linear region, and including several mechanisms of nonlinear process. For example, nonlinear absorption, nonlinear scattering, nonlinear thermal lensing, and both of them, they are not related together. This diagram, in fact, simply explains the three of the main or common nonlinear process which happen for the optical limiting. Indeed, the first one, which is the most common one, is the nonlinear absorption. Nonlinear absorption is simply means that the absorption of the material increases when the laser influence will be high. Through different process, for example, the reverse saturation absorption or the two-photon absorption. Both they contribute to the drop down, the transition in the high intensity levels. The second process of nonlinear is the nonlinear scattering. Through the nonlinear scattering, the material will heat up, and then the thermal lensing will happen, which is drop down the transition also. The third nonlinear process is the nonlinear refraction. In this process, the refractive index of the material will change, and this is spread the laser intensity through the material, and the self-defocusing will occur. Now, talking about the parameters which control the optical limiting for blocking the laser and safety method. This parameter, first we have the beam intensity or laser influence. Indeed, for the pulsed system, the laser influence control the optical limiting activation, and this is in fact due to that the intensity dependent of the nonlinear process in this region. We have two concepts, low influence, high influence. For the low influence, is simply that the intensity of the transmitted will increase with increasing the original intensity. This is a linear one, and there is no heating up. We can say weak optical limiting. This is not used for the laser safety because we want to block the high intensity through the material which in the region of higher influence when we have a stronger nonlinear absorption. Strong nonlinear absorption means the absorption of the light will be increased with increasing the intensity of laser. This figure explaining the relation between normalized transmission and the input influence. It's clear two regions. The first one is this one is the linear region, and this one is the nonlinear region. For the first one, we can spot that the transmission is almost is one, means all the intensity of the light will transmit through the material. This is the linear region, and in the point here, the optical limiting will activate it, or the transmission dropping down through the different process, which including the nonlinear nonlinear absorption, scattering, and also the other mechanism. The second parameter which controls the optical limiting for the laser safety is the laser pulse duration, because the laser pulse duration is directly related to the mechanism of the optical limiting, or a mechanism of the process of absorption, scattering, and also refraction. These kind of pulses, in fact, determine the dominant optical limiting mechanism. The first one, for example, we have the ultra-short pulses, means femtosecond and picosecond. These kind of pulses activate the fast electronic nonlinearities, including the two-photon absorption. The second, we have for nanosecond pulses, strengthen the reverse saturation absorption and is excited state absorption. We have also a nonlinear scattering in this region. For long pulses and CW laser, we have the thermal effect dominates. In this slide, it's clear that the mechanism of the process mainly depends on the laser pulse duration. The table also showing the difference between the long and the short pulses affecting on the threshold of optical limiting. In fact, a threshold optical limiting, as I said before, is the minimum intensity that the intensity or transmission starting significantly drops. If we spot, for example, for the first sample, we have the 10 picosecond and 100 femtosecond, the limiting threshold will be much less. And this is in fact required for the optical limiting and blocking the high intensity lasers. For the all samples, we can spot that the intensity of the laser with the longer pulses will be dropped down significantly. Repetition rate, 2 minutes. Oh, okay. For the repetition rate, which is the same parameter that control the optical limiting, we have the low repetition rate, no heat, and weak optical limiting. Means we cannot use this for the optical limiting will be less. But for high repetition rate, is that the nonlinear absorption or nonlinear process will be activated and the transmission will be dropping down. In fact, the difference between them is just that for high repetition rate, there is no time for the between the pulses that the material will be recovered. But for the low repetition rate, the material can recover. That's why there is a weak optical limiting in the low repetition rate. Wavelength is another parameter which controls the optical limiting, because in fact the optical limiting depends on the absorption. And the absorption of the material mainly depends on the wavelengths, and wavelengths control the energy of the incoming beam. We have the intensity or the wavelength, control the characteristics of the material through the linear absorption coefficient alpha and non-linear absorption coefficient beta. For the short wavelengths, always optical limiting activated, and which is lower the threshold point of the intensity. The final parameter is the incident angle, and in fact this is less important and compared to the others, but have some impact on the intensity of the laser for transmission for the larger angle. I mean, when we have the large angle, we have the large area, and then the laser split, we have a kind of attenuation or big attenuation, and the big attenuation means the optical limiting will be stronger. This is for the large angle. And the figure, in fact, explaining that we have for the large angle greater attenuation, and greater attenuation means the good optical limiting. The key finding for this subject is that the optical limiting normally work as a smart filter to block the high intensity peaks from damaging the devices. The first one and the most important characters or parameter is the laser influence. For the high influence, we have nonlinear absorptions, and this is make the optical limiting larger or stronger. The second parameter is the short pulse duration, which is the important one, and also as we said, activate the optical emitting and nonlinear process. The third and important parameters for optical emitting visual is the high repetition rate. We said that the high repetition rate in term of or in the range of megahertz may activate the optical emitting and lower the threshold of the optical emitting is required for applications safety. The last message for the seminar is that the laser parameters shape the nonlinear response of the optical emitter, and this must be optimized to obtain the effective method for the laser safety and protection of the devices. Thank you.
Thank you very much. Thank you
Sorry,
very much for the nice talk. Any question from the audience? So if there is no question, then thank you.
Thank you so much. It means everything was clear or everything was not clear.
we have take a cover break in order to solve this technical question.
Thank you so much.
Thank you very much. In general, please, we will, in 15 minutes, be here, please. We will now make a break.
Thank you.